We shall be studying about Numpy basics. We need to explore the fundamental Numpy operations to create and manipulate arrays effectively. We need to understand how to generate range data with range and line space, reshape and flatten arrays, transpose dimensions, and create arrays filled with zeros or ones. So, this lesson dives and equips you with practical skills to handle multi-dimensional data for machine learning projects. Chapter goals are quite clear. You will learn about basic NumPy operations, how to write code. First topic is range data. While you know np.array can be used to create an array, it is equivalent to hard coding an array. This would not work when the array has hundreds or thousands or billions or millions or trillions of data. Instead, NumPy provides an option to create range data arrays using np.arrange. Remember, there is a heck of difference between arrange A-R-R-A-N-G-E and A-R-A-N-G-E. A-R, single R, not double R that we usually communicate in English. So the function acts very similar to the range function in Python and will always return a 1D array. The code below contains example usages of np.arrange. So initialize with the entire statement is equal to initialize the variable is equal to np.arrange 5 print repr is equal to np.arrange 5.1 print repr bracket is equal to np.arrange bracket minus 1 comma 4 print bracket repr bracket So what you need to do is just open your notepads, type in ARR or what you can say even UP2P is equal to any name can be said is equal to np.arrange with round brackets and place the number 5. Then type print repr square bracket round brackets is equal to np.arrange and then the round brackets 5.1 it will represent that this variable contains the floating numbers, and when you say minus 1 comma 4 in the round brackets and then minus 1.5 comma 4.2 and then 0 comma 1 comma 0.1 different you can say the results will be obtained. You see here. So the output of np.arrange is specified as follows. If only a single number, say n, is passed in as an argument, np.arrange will return an array with all the integers in the range 0, n. The lower end is inclusive while the upper end is exclusive. For two arguments m and n, np.arrange will return an array with all the integers in the range, and for three arguments m, n and s, np.arrange will return an array with the integers in the array using a step size of s. So like np.array and np.arrange performs upcasting, it also has the d-type keyword argument to manually cast the array. To specify the number of elements in the returned array rather than the step size, we can use the np.linespace function. So this function np.linespace function takes in a required first two arguments for the start and end of this range respectively. The end of the range is inclusive for np.linespace unless the keyword argument endpoint is set to false. To specify the number of elements, we set the num keyword argument. Its default value is 50. The code below shows example usages of np.linespace. It also takes in the d-type keyword argument for manual casting. Is equal to np.linespace 5, 11, num is equal to 4. Print repr is equal to np.linespace 5, 11, num is equal to 4, endpoint is equal to false. Print repr r is equal to np dot array np dot line space comma not comma np dot r is equal to np dot line space 5 comma 11 comma num is equal to 4 comma d type is equal to np dot int 32 print repr. So we reshape the data. In order to reshape the data, the function we use to reshape data in Numpy is np.reshape. It takes in an array and a new shape as required arguments. The new shape must exactly contain all the elements from the input array. For example, we could reshape an array with 12 elements to 4, 3, but we cannot reshape it to 4, 4. What does it mean is that we are allowed to use the special value of -1 in at most one dimension of the new shape. The dimension with -1 will take on the value necessary to allow the new shape to contain all the elements of the array. The code below shows example usages of np.reshape. R is equal to np.arrange8 reshape dash r is equal to np.reshape bracket r comma 2 comma the round brackets 2 comma 4 print bracket repr bracket reshape dash r and the print new shape dot format bracket reshaped dash r dot shape reshaped dash r is equal to np dot reshape bracket r comma -1 comma 2 comma 2 and then the print repr bracket reshape dash r. So reshaping does occur like this, and I just printed, and in the printing part print bracket new shape dot format bracket reshape dash r dot shape print new shape the curly brackets dot format bracket reshaped dash r dot shape. And this is what happens. So while the np.reshape function can perform any reshaping utilities we need, Numpy provides an inherent function for flattening an array. Flattening an array reshapes it into a 1D array. Since we need to flatten data quite often, it is a useful function. The code below flattens an array using the inherent flatten function. R is equal to np.arrange, then r is equal to np.reshape bracket r imported comma 2 comma 4 4 to the 8, so the earlier I said 4 comma 3, so first was 12, then we can write it into 4 comma 3, now it is 8, we can write it in 2 comma 4. So flattened is equal to r dot flatten print repr r print r shape dot format r dot shape print repr flattened print bracket r dot shape colon curly braces dot format r dot shape and then print repr bracket flattened print flattened shape curly brackets dot format flattened dot shape. So this is how we have presented and made all the things quite clear. You see r0 comma 2 comma 3 comma 4 5 6 7 r shape 2 comma 4 and shape, and then the transposing occurs. Similar to how it is common to reshape data, it is also common to transpose data. Perhaps we have data that is supposed to be in a particular format, but some new data we get is rearranged. We can just transpose the data using the np.transpose function to convert it into the proper format. The code below shows an example usage of the np.transpose function. Matrix rows becomes columns after the transpose. So the function takes in a required first argument, which will be the array we want to transpose. It also has a single keyword argument called access, which represents the new permutation of the dimensions. The permutation is a tuple, or you can say it is a list of integers with the same length as the number of dimensions in the array. It tells us where to switch up the dimensions. For example, if the permutation had 3 at index 1, it means the old third dimension of the data becomes the new second dimension. For example, so I say that if the permutation had 3 at index 1, it means old third dimension of the data becomes the new second dimension, since index 1 represents the second dimension. So the code below shows an example usage of the np.transpose function with the access keyword argument. The shape property gives us the shape of an array. R is equal to np dot arrange bracket 24. R is equal to np dot reshape bracket r comma 3 comma 4 comma 2, and this step you remember transpose is equal to np dot transpose bracket r comma access is equal to bracket 1 comma 2 comma 0. Print r shape colon curly bracket dot format r dot shape transpose shape dot format transpose dot shape. In this example, the old first dimension becomes the new third dimension. I run it and you can see the results. So you can see here that the old second dimension becomes the new first dimension and the old third dimension becomes the new second dimension. So the default value for axis is a dimension reversal. The old first dimension, when it becomes the new third dimension, old third dimension, old first dimension becomes new third dimension. Old first dimension becomes the new third dimension. This is what it is saying. The old second dimension becomes the new first dimension, and the old third dimension becomes the new second dimension. So the default value for axis is a dimension reversal. For example, for 3D data, the default axis value is bracket 2 comma 1 comma 0. You can see here comma 2, and when the result was, so what we applied here, the actual thing is axis. So axis here, the old first dimension becomes the new third dimension, because we said, yes, I remember, now I see, 0 1 2. Old first dimension becomes the new third dimension. Old second dimension becomes the first dimension, and the old third dimension becomes the new second dimension. The default value for axis is a dimension reversal. For example, for 3D data, the default axis value is 2 comma 1 comma 0. The zeros and ones, sometimes we need to create arrays filled solely with 0 or 1. For example, since binary data is labeled with 0 and 1, we may need to create dummy data sets strictly one label. For creating these arrays, Numpy provides functions np.zeros, np.ones to create dummy data sets of strictly one label. They both take in the same arguments, which includes just one required argument, the array shape. The functions also allow for manual casting using the d-type keyword. So they both take in the same arguments, which includes just one required argument, the array shape. The functions also allow for manual casting using the d
actually whenever they add in non.
Suddenly almost inside.
Oh.
Suddenly time they
ignore
or any size. Almost any size.
That's right.
In better, na?
Yeah.
This one uses size है.
Yeah.
This one uses size.
Most size. That's the one I can forward. Oh.
Almost same size होगा.
हाँ.
सारे जितने स्क्रीन है.
ठीक है बैठे.
Keywords है. Very same size.
Yeah, the phone.
चिप्स ही वो तो लगा नहीं है बस वो तो करते हैं वॉशिंग एरिया हुआ है वॉशिंग एरिया है इधर नीचे नहीं सर हमारा जो किचन का नाम पीछे उसका वॉशिंग एरिया इधर भी तो लगा था हाँ तो वही है पीछे हमारा भी उसको
Thank you.
ये वाला
ਇਹ ਜਿਹੜੀ ਸੈਟਿੰਗ ਹੈ ਉਹਨਾਂ ਦੇ
ओके
ਜਿਹੜੇ ਜਿਹਨੇ ਲੱਗੇ
ठीक है
ਉਹ ਐਸੀ ਵਿੱਚ ਫਿੱਟ ਆਈ ਹੈ
Size
ਉਹ
proper
ਉਹ product
सही है अच्छा ऑलरेडी बनाया है
ਹੈ ਨਹੀਂ
ये ऑलरेडी जगह बनी
ਇਹ
है
ਬਣੀ ਹੋਈ ਸੀ ਨਾ
ਐਸੀ ਕਰ ਦਿਓ।
ਇਹ ਵੀ ਲੱਗੇ ਹੋਏ ਸੀ
ठीक हो
ਪਹਿਲੇ
सही है
ਇਹ ਅੱਜ ਹੀ ਕਨੈਕਸ਼ਨ ਲੱਗਾ
इंटरनेट का
ਹਾਂ ਅੱਜ ਹੋਇਆ
ठीक
आवाज पूरी से अंकल
जी
आवाज पूरी से नेटवर्क है इंटरनेट में
हमारा नहीं हमारा है इसकी मेरे को देखो
ਸੁਣਾ ਨੰਬਰ ਤੇ ਆਉਂਦੀ ਨਹੀਂ
ऑप्टिक्स
ऑफिस है ना
ਆਫਿਸ ਇਹਨਾਂ ਦਾ ਹੈਗਾ ਜੀ
हाँ
ਇਹਨਾਂ ਦਾ ਸੈਕਸ਼ਨ ਵਾਲਾ ਆਪਣਾ ਹੈ ਉਹ ਵੀ ਹੋਇਆ
अच्छा
उसमें आप रैपिड नहीं है
अच्छा हमारा कंट्रोल इन्वायरमेंट कम करना
जी
आ रही है आ रही है
हाँ, भाई, but किस लिए? असली में किस लिए? सिर्फ फिट कर बाकी यार चार चार मिनट या
So now we will be diving into zeros and ones. Sometimes we need to create arrays filled solely with 0 or 1. For example, as binary labeled with 0 and 1, we may need to create dummy data sets of strictly one label. For creating these arrays, Numpy provides np.0 and np.1s. They both take in the same argument. The code below shows explicitly that array is equal to np.04, np.1s 2 comma 3, np.1s to bracket the round brackets, and then the round bracket 2 comma 3 comma d type of np.int2, and I will be. So now we would be diving into the details further, and so basically now we would be studying about r is equal to np.1s bracket 2 comma 3 print bracket repr bracket r is equal to np.1s bracket 2 comma 3. So which brackets? Round brackets, then the round brackets 2 comma 3 comma d type is equal to np.int2 print brackets round brackets repr round brackets r. And then when we move forward, if we want to create an array of zeros or ones with the same shape as another array, we can use np.zeros like and np.ones like. If we want to create an array of zeros or ones with the same shape as another, use np.zeros like and np.ones like. The code below shows example uses of np.zeros dash like to ones dash like. So what for what purpose? If we want to create arrays of zeros or ones with the same shape as another array, you can r is equal to np.r square brackets, square will not be used, round brackets will be round brackets, then the square brackets, then 1 comma 2, then square brackets 3 comma 4, and as you go print repr bracket np.zeros dash like r is equal to np.array, and then we go on forward and say that the square round brackets and then square brackets 0 dot comma 1 dot and comma 1 dot 2 comma 4 dot print repr np.1 dash like r repr np.1 dash like r comma d type is equal to np.int2. So now it's time to code. Our initial array will be all the integers from 0 to 1, 11 inclusive. We will also reshape it so it has 3 dimensions. First, set r equal to np.arrange with 12 as the only argument, then set reshaped equal to np.reshape with r as the first argument and 2 comma 3 comma 2 as the second argument. So I will be doing live coding for you. R is equal to np.arrange. So that's good. np dot arrange 12 and then set reshaped equal to np.reshape. R is equal to np.reshape so set reshaped is equal to np dot reshape bracket comma 3, and then what we will do is, if we print it over here, we write simply print so I will be execute. So now 2 of 2 test has been passed and history has been made. You can say that history has been made. Now next we want that a flattened version of the reshaped array. For the transposed version of reshaped, we use a permutation of 1 comma 2 comma 0. Set flattened equal to reshaped comma reshaped dot flattened, then set transposed equal to np dot transpose with reshaped as the first argument and the specified permutation for the access keyword argument. Now we say here for the transfer we use a permutation one set flattened is equal to transpose equal to and then we move here flattened is equal to reshaped dot flattened. Flattened is equal to so you see flattened is equal to reshape reshaped dot flattened. Transpose equal to np dot transpose transposed stuff. np dot transpose flattened transpose flattened suppose flattened comma axis is equal to np dot where reshaped comma axis is equal to 1. So just make it right. Two tests passed. We will create an array of 5 elements, all of which are 0. We will also create an array with the same shape as transpose but containing only one as the elements. So now we need to set 0 dash array equal to np dot zeros with 5 as the lone argument. Allahu. Once dasher नहीं क्योंकि once dash r is equal to np dot once dash r is equal to np dot Shukr, alhamdulillah, we have passed. The final array will contain 101 evenly spaced numbers between -3.5 and 1.5 inclusive. And they are evenly spaced. The difference between adjacent number is 0.05. Points go to lines and p lines with first two arguments separately as well as 101 for the num keyword argument. So I go here points equal np dot line space ला हौला वला कुव्वता इल्ला बिल्लाहिल अलिय्यिल अज़ीम np dot minus 3.5 8.5 I go here need hint one of one test pass shukr alhamdulillah and thank you for making this video possible. Thank you to Allah Almighty.